So one of the easy ways to find a maximum and a minimum on an interval of a function is to leverage the fact that we have the extreme value theorem. So if f is a continuous function, so on some a to b it's continuous, then we know that it has to obtain the maximum or the minimum somewhere in that interval. But we can also exploit the fact that we know about critical numbers to say, it may have endpoints on the interval, but there might be a maximum here, so we can exploit the idea of critical points to determine if those maxima and minima exist on that interval. And if it's continuous, we have some neat guarantees because the derivative's pretty much going to either fail to exist or it's going to be zero. So there's this four-step algorithmic process to get there. The first thing we do is we find the critical numbers in the open interval. We don't find them at the endpoints. We find them in the open interval. And then we evaluate f at the critical points. So we figure out what the function output is there. Then we evaluate the function at the endpoints. And after we've done 2 and 3, we take all those numbers together, and the highest value is the maximum, the lowest value is the minimum. Pretty straightforward process. So we've got 3 functions here and 3 intervals, and we're going to try to see if we can do them all in one board. So the first one is f of x is 6x squared minus 9x, and we're going to go from 0 to 1. So the first thing we have to do is to find the critical numbers in AB. So we have to take its derivative. We have to say f prime of x is 12x minus 9. Okay, so 12x minus 9. Now, remember the critical number happens when the derivative is either 0 or when the derivative fails to exist. Well, this derivative is going to exist everywhere because it's just the equation of a line. But for what x value is this equal to 0? So if I say 12x minus 9 is 0, that's the same as saying 12x equals 9, or x is 3/4. So x equals 3/4 is one of my critical numbers. Or actually, it is my only critical number, and it's inside the interval, right? This derivative could have had x equals like 10/5 or something like that, but that's not in the interval. So we wouldn't have considered it then. So that's step 1. Step 2 is to evaluate f at that critical point. So f of 3/4 is going to be, that's 9/16 times 6, so that's 54/16, minus 27/4, which is 108/16. Is that right? No. Yes. So it's negative 54 over 16, which can then be reduced to negative 27 over 8. So negative 27 over 8. So now we have to do part 3. We have to say, all right, what is f at each of these endpoints? So f of 0 is 0. F of 1 is negative 3, because that's just 6 minus 9. So that tells me that the minimum is negative 27/8, and the maximum is 0. So for that particular one, that's how you would solve that. You can feel free to graph this and note that those values are going to hold there. Anyway, let's keep moving on. Sorry, let me get a blue marker. So for g of t, so this one's derivative is a little more difficult. G prime of t is the square root of 10 minus t plus negative t over 2 10 minus t. Now that's all done by the product rule. So then we can get a common denominator, and you end up with 10 minus 2t over 2 10 minus t, which reduces to 5 minus t over the square root of 10 minus t. Okay, so we have to figure out where this derivative is equal to 0 and where it does not exist. So it's equal to 0 when t is 5. And it doesn't exist when t is 10. However, the interval that we care about doesn't include 10. So we don't have to care about that. That's not in our interval of consideration. We only care about this critical number. So that's step 1. Step 2 is we evaluate g at 5. Well, that's 5 times 10 minus 5. So that's 5 square root of 5. Then we get g of 1 for this part of the interval, which is 1 times 10 minus 1. Well, that's 9, so this is 3. And g of 9 is 9, 10 minus 9, which is 9. So I have 3, 5 square root of 5, and 9. So in this particular case, my minimum is 3, and my maximum is 9. So I didn't even need the critical point there. It's kind of neat. So after that, we're going to do, well, let me do this in red. I've got h of x is here, so to take its derivative, I need to get h prime of x. And that's going to be 2 sine of x cosine of x, because that's going to be the power rule brings it down to the 2 in the front. Subtract 1 from the power, but you're doing it of the sine function. So chain rule says that you leave the sine alone, but you have to multiply by the derivative of sine, so you get a cosine. And then you get minus sine of x, because that's the derivative of cosine, which if you pull that out, you end up with a factored sine of x 2 cosine of x minus 1. So this one's going to be a little tricky. Remember, we have to, if we're setting this thing equal to 0, then the zero product property says that if this is 0 or this is 0, the whole thing is 0. Well, we know that sine of x is equal to 0 at 0. We know that it's equal to 0 at 0, and we know it's equal to 0 at 2 pi. But we only care about the critical numbers in the open interval. So in this case, we only care about x equals pi. Now for this one, what we're really doing is solving cosine of x equals 1/2, right? Because if cosine of x is 1/2, 2 times 1/2 is 1 minus 1 is 0. Cosine of x is equal to 1/2 when x is pi over 3 and 5 pi over 3 inside this interval. So we have 3 critical numbers we care about. So h of pi, if we plug in pi to this, that's going to be 0, that's negative 1. H of pi over 3. So sine of pi over 3 is square root of 3 over 2. So when you square that, it's 3/4. Cosine of pi over 3 is 1/2. We already determined that. So it's 3/4 plus 1/2. So that's going to be 3/4 plus 2/4. So it's going to be 5/4. And then you're going to find that at 5 pi over 3, you also get 5/4, because even though sine of 5 pi over 3 is negative, square root of 3 over 2, when you square it, it becomes positive 3 over 4. And so then we have part 3, we have to take it at the endpoint. So when when x is 0, sine is 0, cosine of 0 is 1. And you get the same thing is true there. Those are 1 and 1. So our minimum is here, and our maxima are there. So you have a minimum at x equals pi, and you have two maxima, pi over 3 and 5 pi over 3. And that's, this is the process. You just have to walk through it. You have to solve these and evaluate you follow the algorithm. It's going to get you the answer.